This is Can't This Application Go Any Faster? And I'm Tamar Grainer. And I've been working with Fox Pro and Visual Fox Pro since the late 80s, done a lot of writing and speaking about it. And I'm one of the organizers of this event. And I do a lot of work with other developers, helping solve problems for them, and always happy to talk about new opportunities. Here's the plan for this session. I'm actually going to start with a story, and then I'll talk about what I'm going to talk about. This story goes back to an application that I worked on in the early 20-teens. My client was an engineering firm that built multiplexers that they sold to utility companies, and their multiplexers lived in utility substations and helped manage and track what was going on these networks, on the grid, basically. And this was probably the coolest application I ever worked on, because the application, which they gave away for free to their customers who bought hardware, let them see what was going on, let them check for trouble, fix problems, and so forth on their grid. And we had been working on it for quite some time, and the application was unusual. We were storing information about a given network of multiplexers in an XML. Each one was in an XML file. And when the customer wanted to look at that particular network, they would open that XML file. We would read the data into DBFs, and then we would convert the DBFs into an object model that is a lot of collections and objects, because they really needed the entire network to be in memory at once. We couldn't look at one record here and one record there. So we'd been working on this for quite a while, and a lot of it was working very well. And one day I got an email that was about optimization. And in particular, the issue was not the overall performance of the system, but opening up network files. Particularly for large networks, customers were complaining about how long it took to get that network open and be able to work with it. As I said, we had two phases of what we were doing. And the first phase, going from XML to tables, I was pretty sure I could speed up, because just the year before, Doug Hennig had written an article about ways to use .NET Bridge, and one of them was for reading XML. And he said it was way faster than using the XML adapter class that comes with VFP. So I was sure I could speed that part up. But the part where we went from tables to objects, I was going to have to look at. And that set me on a journey. So today what we're going to talk about is that journey. The first is, how do you measure performance? How do I find out whether what I'm doing, what are the slow parts? That's really the question. We'll talk briefly about Rushmore, but there's been so much about Rushmore over the years that it's really going to be a very small part of this session. I'll talk about a few ways that you can make your code faster in the first place. And then I'll talk about taking out the slow parts. Somebody who was a big name in this community when I first started used to talk about taking out the slow parts. I think it was George Goley, but I'm not sure. So that's the plan for the session. So let's start by talking about measuring performance. Because after all, how can you make something faster if you don't know how fast it is to begin with? So the fundamental way that you measure performance is you collect the start and end times for a thing, and the difference between them is how long it took. And the slide shows you can do that with seconds. There are a couple of issues if you do it with seconds. The first is it's seconds since midnight. So if you're actually testing across the boundary of a day, you're going to have some issues. You'd also need the date. But seconds is good because it actually gives you milliseconds. It has 3 decimal places. If you are testing across a day boundary, you could, in fact, use date time instead, but date time doesn't give you the same precision. So there's a choice to be made there. Um, the standalone examples we're going to look at are use seconds. We'll see that in some other instances, I am actually using date time. The other thing that happens is often the thing you want to test, even though it might be slow in terms of your application, is really too fast to test doing it once. So when you want to test which thing is faster, is it faster to do it this way or that way, you probably want a loop. You want to do the thing a bunch of times and see how long it took. So let's look at an example of that. So I'll start with a pretty classic one. Which is faster, do while or for? Many of you probably may know the answer to this. And so what we're going to do is say, I'm going to do this 10,000 times. I'm going to grab the start time. I'm going to loop for as many times as I just said, 10,000. And inside the loop, I'm going to do the thing I want to test. And after I've done it 10,000 times, I'm going to grab the time. And then I do the same thing for the other one I want to test, in this case, the for loop. And then in this session, I'm going to do this a lot. After I've done a test, I'm going to open the debugger and use debug out to show the results. So let's go ahead and run this. And here we go. 10,000 passes of do while took about 0.6 of a second. 10,000 passes of for took just under 0.06 of a second. In other words, for is an order of magnitude about 10 times faster than do while. So lesson number 1 in this session, which really fits in the make it faster in the first place, is whenever you can use a for loop instead of a do while, use a for loop. However, I want to say some more about the fundamental issues of testing. I wrote an article about this stuff, I don't even know how many years ago, and it was for the Fox Per Advisor Q&A column. And Christoph was one of the writers, and we always looked all at each other's work. And he said, I don't like to do it with the number of passes loop. I like to run it for a fixed time, like this. And I'll talk more about why that is when I get this running. I'm going to define the seconds to run, and then I'm going to grab the start time and calculate what I want the end time to be, and then use a do while loop till I get to the end time, and I'm going to count how many passes through this loop do I get in my 5 seconds, and the same thing for the second example. So this is going to run for about 10 seconds, and I'm going to talk about why to do it that way while it does. And the big reason is that it's because you then know how long it takes. When I did that first example, the first time I wrote that example, I think I did many fewer than 10,000. I might have done 1,000. But 1,000 passes, 1,000 passes was so fast, I didn't feel like it was a good measure. And I had to experiment to find out that 10,000 was the right number. This way, I'm going to run it for 5 seconds. And for almost anything I want to test, 5 seconds will let me run enough passes to give me meaningful data. And you can see, again, 84,000 passes in 5 seconds with do while, 842,000 for the for. Again, it's an order of magnitude faster. So we're going to see a lot of examples that look like this one in this session. A couple of other things I should talk about as basics before we move on. Set talk off before you do any of this kind of testing. You don't want any echoing to the screen to be changing what you're doing. Also, while I'm only going to run things once in this session, it's generally a good idea to run the test multiple times. And the reason for that is that we're running in Windows, and there's all kinds of things going on in Windows in the background. I've closed what I can. I have my email client shut down. I have a couple of other things shut down, but I see some things I didn't think to shut down. Like I've got Dropbox running, it's probably doing some things. And I have OneDrive running, and it's probably doing some things in the background. The more of that you can shut down before a test, the better. In my testing for this session, I tested on this machine. I also tested on a laptop. And the laptop, I actually shut down the internet connection while I was testing so that I took away one more variable. Okay. So what I just demonstrated is great if you want to say, is technique A faster or is technique B faster? But inside an application, if you need to actually run the application, you need some way to track the progress inside the application. And in this particular example, I had already implemented text logging for this application. There were a lot of reasons we needed to be able to log to a text file. So I used my text logger to collect performance information as well. And what that looks like is this. This is a simplified version of the class that was in my client application. It has a property to hold the name of the log file. It has a method called logit that takes the string you want to log and a parameter saying whether or not to start a new file. It checks whether we've got a log file. If not, it uses a default name and sticks it in the temp folder. And then just using string to file. And I'm converting the current date time to character. So every line in the log has a timestamp, logging the string, carriage return line feed to the specified file. And if the parameter says to start a new log file, then I'll start a new file. And then I have another method here just to show this log afterwards. And so here at the top, I'm showing a very simple example, but very similar to what I actually did in the client application. Instantiate the logger, call the logit method when you start, and then you want a new log file, and then do something. And at the end of that step, call the logger again to say you're starting the next step, and so on, and then at the end. So when I run this, it's not going to be terribly interesting because it's all very fast because there's no actual code going on here. But you can see that the logger here does let you collect timing information. For what I was doing for my client, I just manually did the parsing, figured out how long each step took. You could also write some code to parse a file like this because it's very regular. So a text logger is a good way to track. In other situations, you might prefer to log to a table or cursor. That's fine too. But you need some way to log from the application that you're testing so you can see, are you making progress? The other thing you need to do is track that progress. The client I was doing this for used Bugzilla, and we had a bug dedicated to this process of speeding up opening a network. So in my very first message in that bug, I created this ASCII table showing my actual tests, how many nodes were in the network I was testing. Phase 1 was XML to tables. Phase 2 was tables to objects. And I ran each test twice. And then every time I tried something new, I would add a comment to this bug telling what I tried, copy and paste this ASCII table in, and fill in the correct times for that test. Make sure you log everything you try, the things that make it faster and the things that don't do so you don't repeat yourself and try the same thing again, so you know what actually made a difference. There is an entirely different way you can look at performance in VFP. We have a pair of tools, the coverage logger and the coverage profiler. They're obviously related. And they allow you to log, without having to write code for the logging, every line you execute in a given run, from the minute you turn coverage on until you turn coverage off. And that's really handy. And there are a number of ways we can look at it. Let's first take a look at coverage logging. So there are a number of ways you can turn coverage logging on. The easiest is to go to the debugger and then either click this button, toggle coverage logging, or go to the tools menu and choose coverage logging. And what you need to do here is specify the name of a file to which you're going to log. And I'm going to log to cover.log, and I'm going to overwrite the file I already had. I'm going to start that, turn it on, and then I'm going to come back over here, and I'm going to run the solution samples just because it's an easy way to do a little testing with something that already exists. So I'll type something here. What I'm doing here, I guess I should, is the specifics aren't all that important. Oh, I guess I needed to. I can uppercase, lowercase. I can refresh how many characters. We'll close that one. I'll do run one more example. List box. Move items between list boxes. Again, I know you can't really see this. It doesn't really matter because I'm just doing this to have some lines of code that executed. Okay, so I'm still have coverage logging running in VFP. I can now open the cover, and that wasn't where I wanted to go. Open the coverage profiler, and it will actually start working on that log. The coverage profiler is a tool that comes with VFP. We're going to open it from the tools menu. I want to make sure to say that don't use coverage logging. Don't use the times you get from coverage logging to compare to times you get when you are not doing coverage logging, because in fact, they are, sorry, I'm trying to make that top panel larger and I can't find the right spot. Oh, well. The coverage logger slows things down, so you can't compare it to not logging. When you open the coverage profiler, you are in what's called profile mode. The mark that you see on the side says that line executed. In the top here, we see all the different I can get there. There we go. We see all the different routines that executed. We're not interested in the coverage side today. Today, we're interested in profile mode. Excuse me. In profile mode, for every line that executed, for every line in the routines that executed, we see how many times it ran, how long it took the first time it ran, and the average length of time it took. And let's go. One important thing that you need to know about this is that if a line ran another line of code, let's try this again. If it called a routine like this line, we didn't run this one, but the time that you see is the rolled up time. That is, it includes the time that it took to run that method or routine that got called. So here we can see various information about how long things took. You can see on this line, for example, that the first time it took a lot longer than the average. Given that it's a call to in key, that's not really surprising. So you can use the information here to try to get an idea of which lines are slow or which are fast. I find, though, that the profile as shipped, the coverage profiler as shipped, is not all that helpful. Let me say one more thing before I move on, which is starting in VFP9, you can run coverage logging at runtime. You didn't used to be able to, and generate a log, which you can then bring back to your machine and but when you do so, you may have path issues. As you saw, I had to point to the path of something on the way into this. Rick Schumer created a tool that will let you modify that log and save a new version with the paths that are on your machine. That tool is included in the downloads for this session. Okay, so coverage profiler as shipped, not as useful as you'd like, but it accepts add-ins. There's an open architecture and you can add things to it. There's an add-in created by Marcus Egger. It's called MaxCov. It's also included in the materials for this session with Marcus's permission. I'm not going to demonstrate it here because instead I'm going to demonstrate an add-in that actually comes with the solution samples and I think is a little more useful than MaxCov, a little easier to use. So you can get to the add-ins up here on the toolbar in the tool. It's this thing with a plus sign. I already registered this particular add-in before this session, so I'm just going to be able to run it. You'd have to go find it and run it. This does have options, and I think I can bump those fonts. Yes. Unfortunately, it doesn't remember that I bumped the font from run to run, but let's do that because it will make life much more pleasant. Okay. So this add-in shows every line of code that ran, and I don't know what the initial sort is, but you can sort by the number of times it ran, and second click on the same line reverses. You can sort on how long the first run took, and so forth. I think the first run or the average are the ones that are most interesting because they'll show you the slowest lines, total time spent there. So here I feel like I have enough information that I could start going and digging in and saying, well, these are lines I ought to take a look at. This also includes some reports. So this shows the slowest 25% based on the field first, which were the quarter of the lines that were the slowest. You can actually, in that options dialog, which was this one, set which column to use, the percentage and which column. And in fact, you know what, at this point, let me grab the magnifier because I want to show you what's in this options dialog. Let me move it over. So you can tell it, and I didn't show you the highlighting yet. You can say, what is the time threshold? What the tool lets you do is highlight the lines that are slow. And you can say, how slow do I mean by slow? Here, it's anything that's more than 1/100th of a second. And based on which column, we'll do with average. I'll go back. I'm going to get out of the magnifier if I can. Ooh, wrong, cancel. Hit the wrong thing. I may have just messed this demo up trying to get out of the magnifier. Yes, I did. Well, the add-in anyway is lost. Yes. I still have the coverage profiler open. I do not. Sorry about that, folks. Okay, so now what you see is I actually have to point to a coverage log. I'm actually going to switch to a coverage log that's included with the session materials and that has a little more in it, although it's still run against the solution samples, but it's a little bit longer. I did a little more, and that's what we're going to use, what you're going to see in the next example. I have to give it the main program. Okay, so now let's go back to that add-in. Apologies for the glitch. And as I said, it doesn't remember that you've changed the font. There are things I would definitely change if I were going to use this for production. I'm going to go back to looking at the average. All right, so what I failed to show you the first time was you can highlight the slow lines. So every line that's highlighted took more than an average of more than 1/100th of a second. So that is a nice thing that this does. And of course, we have the sort to do that too. So this add-in, I did not know about it when I was doing this client work all those years ago. I wish I had. It would have saved me some effort. So Let's get out of the coverage profiler. It turns out, though, that coverage logs are just comma delimited files. And so you could actually work with them manually. You could read the data into a table, cursor, and do things with it. Let's take a look at that. So first, here's the log. I'm sorry. This is this create cursor will pull whatever will hold the data that's in a coverage log. It has the time, the class, the object, the line, what file it was in, and the stack level. And that ought to be n stack, but I'm not going to change it now. And then I'll append. So I'm just going to run this much. And I'm going to grab this solcover.log, the same one we were looking at the end there. And let's just go ahead and browse that. This one has almost 70,000 lines. And again, browse is one of those things where, well, I'm going to change the font. So you can see it's pretty basic, the time that it took, what class it was from, which object or which method here, the line, what file it came from, and the stack level. So we could do lots of things with that, right? And so I've included in the materials a bunch of queries that query against that cursor. For example, what are the lines we ran the most times? And I have them in descending order. Unfortunately, again, this isn't getting remembered. Or maybe I didn't run this example when I practiced the session. So certainly the lines that run the most are ones I might want to look at. One that I used a lot for my client was I got a list of all methods with their total execution time in descending order. And then I spent the most time in the methods that had the longest execution time. For this example, again, it's not as interesting as it would be for real code, but you get the idea. So just importing the coverage log and running queries against it can give you ideas what you need to look at. And then there's one more thing you can do with coverage logs. Because it's a really open architecture, there are alternative profilers. Well, there's one that I know of, but the ability to have alternative profilers is out there. Martina Jandrova created a tool called CVP, which can read a coverage log, and you can actually set a system variable in VFP and use it instead. And as you can see on the slide, it gives you the ability to pull up lines with various characteristics, lines or methods. So on this example, I said, show me every method or procedure that was above 1 second, and show me the first 10. I'm actually confused exactly what I'm showing on this slide. And you get to do it by execution count. I think I'm going to not actually show you the tool itself because I think the slide actually makes it pretty clear the kinds of things you can do there. So, are there any questions to this point?
None at this time.
Great, then we'll just keep going. As I said, we're only going to talk briefly about Rushmore. Rushmore is the technology that really made FoxPro stand out from the other X-based tools. It's an optimization technique that applies to X-based commands that have the for clause and SQL commands. and it uses index tags to speed things up. I tried to draw a diagram of what it is that Rushmore does. Imagine that you have a command and it has a for clause or a SQL command with a where clause that is city equals Portland and state equals Oregon. What Rushmore will do is go read the index tag for city, assuming there is one, and it will pull out the part of that index tag that has the value Portland. Then separately, it will go read the part of the index that's for state and pull out the part of that tag that has the value OR. And then it uses bitmaps to say, well, which records are in both of these results? So in this example, we'd see the second record for Jones and the last record for Garcia. The rule is that the expression that you are doing a comparison with, typically inequality, but typically equals, it doesn't have to be, that the expression must exactly match the key to an index tag. So in the example here, there has to be an index on city and an index on state for Rushmore to help. If the index is upper of city, as it may well be, then in my for clause or my where clause, I'd need to be sure to say upper of city. Similarly for upper of state. What makes it fast is that it reads only part of the index. It only reads the part that matches. And typically reading that in is going to be a lot faster than looking at all the records on disk and figuring out which ones match. However, there is one complication to that. When Rushmore first came into VFP, which I think was Fox, it wasn't VFP, it was FoxPer 2, pretty quickly people said, hey, with Rushmore, you should create an index tag on the deleted function. Why should you do that? Because if you are operating with set deleted on, so you don't see deleted records, that's equivalent to having a filter in your where clause or in your for clause for and not deleted. It's equivalent to adding and not deleted to a filter. And the deleted tag means you can use an index for that. And for some tasks, that turned out to really make a big difference. Until a few years into all this, some folks, I was the editor of FoxPro Advisor at the time, and I got this article. And I think Alan Greiver actually sent the article my way, although it wasn't written by him. And it was about a project they were working on that had enormous tables and worked across a network. And they had discovered that in that case, having a deleted tag made the code much, much, much slower. Why? Well, because for an index tag on deleted, the odds are that almost every record is not deleted, that the portion of the index tag for not deleted is way bigger than the portion for deleted. And that across a network, reading that part of the index tag into memory was just slowing everything down. For this session, I don't remember the numbers, but I created a table with about 1 million records, and I created an index on deleted, and the size of that CDX was enormous. So what we learned was that for large tables that have where most records are not deleted, if you're working on a network, you do not want a tag on deleted. The story changed a little bit in VFP9 because in VFP9, the FoxPro team added a special kind of index only for Rushmore. It's called a binary tag. You say index on this thing, tag its name, binary. And what that does is it creates a very compact tag because it knows that it's only good for places where the key has only 2 values. So index on deleted, where it's either true or false. Or for anything else where there are exactly 2 values, you can use this, and then you have a tag that Rushmore can use, and it is way, way, way smaller than the normal tag you would create. You cannot use that tag for seeks and things like that. You can't search using that tag. So what happened with that new kind of tag is the cutoff between when an index on deleted is useful and when it isn't changed a lot. So how do you know what Rushmore is doing? In XSpace commands, there's nothing we can do to find out if Rushmore is helping other than test, is it faster or slower? But for SQL commands, we have a pair of functions that let us find out what Rushmore is doing. Sys3054 turns on what's called SQL show plan. This function takes a parameter that's a value 0, 1, 2, 11, or 12. 0 means turn it off. The 1 and the 2 determine whether you want to find out what the query is doing only with filters or with filters and joins, 1 for filters, 2 for filters and joins. And you add 10 if you'd also like to show the actual query in the result. The third parameter here says put the information into a variable called C3054 output. By default, Sys3054 just echoes right to the screen. And that's not very useful. So you can pass the name of a variable and it will put the result in that variable. So here we've got a query. I actually grabbed something from the Northwind database. This is the SQL for one of its views. I'm going to turn on Sys3054 for filters and joins, run the query, and then I'll turn it off, and then I'll show that variable. So at the top, it shows me the query, unfortunately not very well formatted, but I can see what query I'm talking about. Then the first half of the result here is about filters. Any line that says Rushmore optimization level says, how are the filters in this query? How much are the filters in that table optimized? And you'll notice we have none for several of them, but that's because there are no filters on those tables here. It could be none with filters because there's nothing optimizable. In this case, we're not optimizing on categories, products, or order details. The using line says that we're optimizing the table orders using the shipDat tag. Well, if you look at the query, the orders, the where clause has a condition on ship date. And so we're optimizing using the tag for that field. It also says, though, that it's only partial optimization for that table. That's the problem I was just talking about. Set deleted is on. I don't have a tag on deleted. And so it is only partially optimizing. In this case, not a big deal, because checking whichever records match to see if they're deleted isn't going to take very long. The second part here looks at the joins. There are 4 joins here: categories to products, back to orders, and then on to order details. And it shows us both the order in which they happen and how they're optimized. So the first join that happens is categories is joined to products, and it's using the category ID tag of products. It always shows the table whose tag it uses second. The second thing it does is join orders to order details using the order ID tag of order details. That makes sense. Order details is a lot bigger than orders, so we want to use a tag from that one. It then joins those 2 intermediate results using a temporary index that it built. The engine decided that was faster than being sure it had a tag to use on every join. Okay, so this is neat. It's convenient, but there is one problem. And the problem is that Sys3054, when you send it to a variable, will only give you the result for the last query that you run. So in a test code like this, no big deal. But if you want to turn it on in an application and get the results from a lot of queries, this isn't going to work. So in VFP 9, they gave us a new function, sys3092, that says send sys3054 results to a file. You turn it on by calling the function and passing the name of a file. You can, of course, include a path if that's appropriate. Then you do sys3054, the query or queries you want to run. Turn off sys3054. You turn off sys3092 by passing the empty string. So when I run this, I get the same results, except now they're in a file. So that's how you can find out what Rushmore is doing for you. Any questions at this point?
No, none at this. Oh, wait, there was one. I remember that it's necessary to close the coverage log before using it. Is that true?
Actually, no. If you're going to use the coverage profiler that comes with VFP, if a coverage log is open, it will automatically use it. And in fact, then when you close, if you don't close badly as I did, it will ask, do you want to keep it open or do you want to close it?
That's it.
Okay. So let's talk about making it faster in the first place. In general, you don't want to focus too much on optimization too early, because you want to make it work. You want to write solid code. But there are certain things you should know that will just make your code faster and that you should just do. The first one may be a real surprise to you. You should use MDOTs. Everybody here, I think, knows that we put M period in front of a variable name to distinguish it from a field, because FoxPro, by default, assumes you mean a field if there is one with that name. It turns out, and there, I know there's also a whole school of thought, a lot of people who use a naming convention and don't think they need to use MDOT. I disagree with them. But it turns out MDOTs also improve performance. So what I did to test this is I wrote a piece of code. The code we're actually going to test is a really simple bit of code that's just going to take two variables and compute perimeter and area. We have length and width. So one version doesn't use MDOT, one version does use MDOT. But what I did to test this is I stepped through from 0 fields to 200 fields by fives, and I created a cursor with that number of fields. So the first time I just went to an empty work area. After that, for 5, 10, 15, I created a cursor with a field list that was however many fields I'm supposed to be including this time. I could have gone all the way to 255, 254, whatever the magic number is, but up to 200 seemed sufficient. And then in each test, I just ran my test to compute perimeter and area and saw how many times I could do it for each one. I'm not going to run this because it's running a whole lot of tests. What I'm going to do instead is show you the results that I got. And once again, I need to bump the font. So when there was nothing open, you can see that with or without MDOTs, we did pretty close to the same number. That is, the ratio was almost 1. That's just randomness of its windows. But already by the time there were 5 fields for the table in the current work area, I was able to do 4% more passes with MDOTs than without MDOTs. And continuing on down the line, by the time there were 95 fields in that cursor, we were doing twice as many passes with MDOTs. And down at 200, it was 3 times as many passes with the MDOTs. Now, when you look at this result, what you see is with MDOTs, pretty much we're doing 11 million passes in 5 seconds, which is a lot. But there are only a few variable references in there. But it's pretty steady. The number does not change. Without MDOTs, that number drops considerably. At the end there, we're under 4 million. Again, the those are still incredibly fast. But in a real application where you are referring to variables all over the place, having M-dots could make a real difference in how fast your code runs. So that's the first thing to do to make your code faster. What else? Use the right loop. I showed you earlier in the session that for runs about 10 times faster than do while. So always use for if it's the appropriate, if it's a counted loop. I wish scan had quite the same improvement. It doesn't, but it runs, depending on the test, anywhere from 30 or 40% faster up to twice as fast. Here's the test code. We're going to just take a table, go top, do while not end of file, skip. And then for the scan loop, all we have to do is select the right area, scan, end scan. I really think that's part of why it's faster, because it's fewer commands. And when I run this, and it'll run for 10 seconds, we'll see that it is somewhat faster. So in this test, about 30%. I know I've seen it be as much as twice as fast. Use scan rather than do while when it's the appropriate, when you're looping through a cursor or table. We have the for each command. The for each command came into VFP with VFP 5 when we started having some collections that were available to us, and when we got automation. For each lets you go through a collection. It works with arrays too, but I can't say I use it that way. And it says, for each member of this collection, hand me that member. It'll put the member into a variable, and then you can work with the member in the list. Because all the collections that we had in FoxPro, almost all of them were COM collections, not native FoxPro collections. For each hands you a COM object. And that has some consequences in how it behaves, but also in speed. In VFP 9, say it this way. In VFP 8, we were given collections, a native collection class. And that's when we discovered, wow, for each is slow on native collections. So in VFP 9, we got the Fox object keyword for the command that lets us say, this is FoxPro objects. Actually, what it says is, if this is a FoxPro collection, hand us FoxPro objects. And that turns out to speed things up considerably. So my test code here, I'm going to create a collection of 5,000 objects, and then I'm just going to go for each through them, or for each through them with the Fox object keyword. Let's run that. Did I get it? I think I got it. Yeah. And we can see that that's way faster. That's 2 orders of magnitude faster with Fox object. So absolutely, when you are traversing collections, especially if you know they're native, add the Fox object keyword. Okay, so that's another way. The right loop will speed your code up. So this is new to this session. This is something that came up in a client application I'm working on now. I'm working with somebody converting, it's an application that was written originally in FoxPro Windows, and it's been running for the customers in VFP for many, many years, but we're in the process, we're nearly finished converting the forms to native VFP forms. I know it's a long time. It's a huge application, vertical market app. And it's based on a FoxPro for Windows framework, which we have done enough conversion with to not have to rewrite the code. Customers were really complaining that forms were just way slower than they had been in the old version, in the FoxPro for Windows version. And We knew that some of that was because we changed the design a little bit and we're doing some things differently, but still there was a lot of slowness. And we couldn't figure it out. I did a lot of work actually cleaning up so we're not refreshing too often, things like that. And still it was too slow. And my client, had one of his people run process monitor. And for a form, in one form that somebody was complaining about, we were accessing a particular table tens of thousands of times. And there just was no reason for it in that form. And so we went digging, and what's going on in the form is this application has the ability for buttons to add an ellipsis if there is data behind the button. That is, buttons that let you go look at something auxiliary to the form. And if in fact you've already added any of that auxiliary data, we put an ellipsis after the caption so the user knows, oh, we've got something there, I should take a look. And that code that adds the ellipsis and removes it is living in the refresh method of our base button class. So what I discovered was that if we had code in the refresh method of our form classes, we were running the button refresh code over and over and over. And I'm going to show you what this looks like. This is the form. And I put a few things in here. In refresh, I'm going to debug out the program. I'm going to call do default, and then I have a little bit of extra code that sort of gives away what's going on here. We'll talk about that in a minute. And I have that at each level in the form hierarchy. There's a base form class, there's a form class, and there's code in the form. The notes button is the one that gets the ellipsis. And the way it works is in the refresh method at the class level, which is why the font hasn't been changed, because it won't, this piece in FoxPro doesn't bump fonts. We check, do we already have an ellipsis on this button? And then we call a custom has data method. If we have data and we don't have an ellipsis, add it. If we don't have data and we do have an ellipsis, remove it. And the has data method is abstract. Normally, it's a query or two to go say, hey, is there any data of this sort? For this demo, I'm just randomly half the time adding an ellipsis. And then in the refresh method, I'm debug out the program and call the do default. And I'm also doing that in the refresh button. So when I run this, let's go clear this. Let's bring this up and let's clear it the first time. And now when I click the refresh button, whoops, that is not what I want. When I click the refresh button, you see what was on the slide. Refreshing all the forms, and then each button calls its refresh 4 times. So as the code gave away, I never thought of refresh as something where you needed no default. But refresh is something where you need no default if you have code there. So I'm going to click the button, which is setting a property. And now when I refresh, whoops, the wrong. I only refresh each button once. I only run its code once. This is not the first place in this set, or it is the first place. It's not the last place in this session where the solution to something is going to be da, of course. But since I've been working in Visual FoxPro for 30 years and never realized that refresh should have no default, I suspect I'm not the only one. Okay, questions on making it faster in the first place?
Yeah. When using fields from tables, does it make a difference if you use the table name or without the alias /name?
I don't know that I've ever tested that, but it shouldn't, because by default, FoxPro assumes you mean a table, and it's going to go look first in the current work area. So if you're referring to a field of the current work area, it shouldn't matter.
Okay. And someone else asked, does it help to use MDOTs with objects?
Probably. Again, I didn't test, but they're variables. And so if you have O something, it's going to go check your current work area and say, is there a field named O whatever that is?
Okay, that's it.
Okay, great. So let's talk about taking out the slow parts. With my client application, after I'd implemented uh, the Doug's solution on the XML, then I had to look at the part where I was going from tables to objects. And there were a lot of things I looked at. First, obviously, except again, it's easy to do, unneeded code. In this application, certain properties, whenever we updated them, we also updated an associated timestamp. And when I started looking at this, I discovered that over time, we didn't write it this way in the first place. Over time, I'd accidentally been doing it right when I updated it in the code, but also in an assign method, doing the same thing. Obviously, you need only one of those. So I took the unneeded code out. Again, you don't write it that way, but over time, code gets messy. And you find that, oh, I did that there and I'm doing it there. I don't need to do that. A thing I did a lot of on this project was questioning my best practices. You already have inferred that using MDOTs is a best practice. And in fact, it's a best practice that this application really set in stone for me, but not the subject of today's stuff. One of my best practices, one of my theories of best practices, I guess is the right way to put it, is that I want every line of code to be as independent as it possibly can and rely as little as possible on other lines of code. One of the ways I like to do that is to instantiate using new object rather than create object. Create object, I have to be sure I've either set procedure or set class lib. New object, I don't. And that was one of the reasons that was how I was doing things. But when we started looking at this, I said, I have a vague memory that new object is a little bit slower because it has to go find the class lib. And I went out and tested, and sure enough, create object is about a third faster. So for this, included in the materials, I created a set of classes that create business objects and collections for a school. Then the database is included in the materials. And in the business object base class here, there's a load method. And in the load method, we actually load data from tables into this collection. And so in one version of this, I do it with new object. And the other version, I don't think I need to show it to you, I do it with create object. And so what did I learn? I then wrote code to completely load this school data. The load data method calls with the department's collection calls load, and then the instructors, and then the classes, and then the students. And you can see me using that login, the text log here as well. And I have two versions, one for each set of classes. And when I ran them, here's what I found. The version using new object to load the not quite 60,000 objects needed to represent this database in an object model took 18 seconds. And when I did it with create object, it took about 13. So as I said, it's about a third faster. That's significant. What else did I look at from my best practices? Finding the right record. I like to use a query to find a record because it's just less cleanup afterwards. I don't have to worry about I've moved the record pointer in a table and I got to go back there and all that. So in this process for this client, the loading of this data does a ton of lookups into metadata tables. that looked something like this, but could look something like this. And this one, I will show you the demo. So we're actually going to look at 3 cases here. What I did was I went to one of the tables and I randomly chose 500 records from that table and put them into the record IDs, the instructor ID from those into an array element. I have an array of records I want to find. And then I have the first test case is run a query. We're talking here about the situation where a query will find exactly one result, not the situation where there may be a whole set of results. In the stuff I was doing in this client application, I knew I was going to find one record. The second version, I select up top, set the order, the tag I want, and just do a seek. Obviously, in an application, that's a little risky not to make sure you're on the right tag before the seek. And then the third version, I use the seek with the in and order clauses so that I know I'm seeking in the right table with the right tag. And I'm sure it's no surprise when I run this that the one where we have seek in order is going to take longer than the one with a regular seek without that, because it's got to do that every time. But look at the difference even between the query with one record result 205 times and the seek within an order 13,000. So again, 2 orders of magnitude faster. That's a lot. So yeah, I changed that code. Before I move on from this, I should say that while in this case, switching from SQL to XBase code was speeded things up, it is often the case that you can take a big block of XBase code and write a single query or a single SQL command that is way faster. But for this particular thing, not. Another thing that I questioned is that I like to write one of my things, because I like every line to stand alone if it can. I like to write work area agnostic code. What I mean by that is what you just saw. I'll write seek value in work area order tag. But I wondered how much that was costing me. So for that, I did it with seek, but I could have done this with any XBase function. And I should also say, I also like to put the tag in any function that accepts the alias. So in the seek function, I would pass the alias in. So I ran 6 cases here, which means I'm not going to run the example. I could, but I'd rather have time for discussion. I tested the seek command. You know what? I'll show you the code. That'll be much easier than just looking at a slide. So test 1, top. Test 1 was I selected the table, I set the order, and I just did seek. Test 2, I assumed that the table had the right order already set, but I did a seek in. And type 3 here was as before, seek order in, or in order, whichever way you want to put that. And then I did the same thing for the seek function. Select and set ahead of time and just call the seek function, or seek and pass the table but assume I'm on the right order in the table, or pass both of them. So I ran that code, and back on the slide we can see that there were significant differences. An important thing is that only cases 3 and 6 are totally safe. The other cases, things can be not as you assume they are. In particular, in the client application I was dealing with, there were some things going on that meant I couldn't make too many assumptions. There were a couple of timers running in this code, and when the timers fired, code ran, and I couldn't be sure. I mean, obviously, you want the code that runs to clean up after itself, but I couldn't be 100% sure that it did it right. I think we were also using some bind events in that application, and that also fires code that might change the situation. By the way, those timers and bind events are the reason that I like to put the alias right into the command, because something could fire between two lines of code. So here, there are differences, but I actually think for safety, you want to use the safe version anyway. Questions about taking out the slow parts?
Yes. Have you tested seek versus index seek?
Um, Not in a very long time. I thought index seek was going to be wonderful, and I have rarely used it. Um, but my vague memory from a really long time ago is that it's a little bit slower.
Okay. I think the rest have been answered by others.
Okay, well, that's great. So let's sum it all up. You should use tools to figure out what's slow. And I've shown you several different kinds of tools you can use to do that. Tools for testing language structures independently, tools for testing inside an application. If there are things you know are faster and they are safe, you should just use them from the outset. And when you're looking for the slow parts, you need to question things that you do automatically, because it might turn out that even though it produces code you really like, they may be slowing things down. Some resources. Code Complete is a classic. It's pretty old by now, but it has a couple of chapters on optimization. Not all of it applies for VFP, but some of it does. In HackFox, Hacker's Guide to Visual Fox Pro, we have a section called Faster Than a Speeding Bullet that talks about things that are fast and not fast in VFP. There are some other resources listed in the paper. I just want to add also that I talked about some specific code choices here. That was not exhaustive. This was things that I ran into. Oh, and I forgot to say, the other duh moment in this client application turned out to be that we had these metadata tables, and we had kept adding more things to the metadata, more fields, and had forgotten to add some tags as we were doing that. So it ended up that even though tags were the first thing I thought of, I didn't catch it until much later, and we needed to add some tags to our metadata, and that made a huge difference. So going back to lessons, the key thing that I hope you walk away with from this session, although I hope you remember the specifics, but the key thing is the whole idea of how do you find out what's slow so that you can go in and try to solve it. As always, please fill out your evaluations. We learn from them. And I'll take any final questions if there are any.
No, but they're probably furiously entering them in now.
Yeah, okay, well, I will go over to the session room, and this way people get a little bit longer for their break, for their long break if they want it. So thank you all.